Hey, can you hear me? So let's wait 1 minute that the room is empty. Okay, so let's go. Can you hear me well, everyone? Yes? Okay. So I'm Xavier Coll. I'm from Westinghouse. I'm the responsible of everything related to outages for the geographies of EMEA, Latin America, and Asia. It is a pleasure to be here today and to be able to talk about nuclear assets, and thanks for your participation. So the title is not really self-explanatory, but we are going to talk about basically maximizing the nuclear assets. I'm going to set a little bit the stage to introduce the subject, not discovering many things, for my two colleagues that are coming after to give you more details. Before I start talking about energy in a broad way, just I would mention that, now we are everyone saying we are in the nuclear, in the next industrial revolution, next industrial era, digitalization, artificial intelligence, things that are important for everyone. Not only for these things that are important for everyone, but for many other important matters. It is obvious that energy is going to be crucial, right? Energy is going to be, as we dare to put here, a kind of a slogan for the nuclear United Nations, that energy is going to be key for most of the major challenges that the world is going to face, right? I would like also to highlight on the right, two key facts, key figures. So over the next 20 years, the world population is expected to grow 20%. And there is not a correlation between that population growth and the electricity demand. As you can see, in 5 years, the electricity demand is more exponential, not connected completely with the population. So the electricity demand is going to nearly double in the next 5 years, right? Important figure to have in mind. Then, obviously, for everyone here, that finding solutions to increase energy needs while confronting the realities. Realities is that we need sources to provide electricity that don't emit, don't generate CO2. This is obvious, but this is something that is going to put a lot of pressure under us to generate that electricity without emitting, without affecting the climate, right? So in that idea that we need to shape tomorrow's energy together for a cleaner and better future, it is obvious that nuclear is going to have an important role, very important role. So it doesn't matter with your colleagues that are more or less pro-nuclear, how pessimistic, optimistic we are. In all the scenarios that we can envision for the future, nuclear is going to grow very significantly. It doesn't matter if you pick up pessimistic, optimistic scenarios, nuclear is going to be there for sure in a very important way. And the reasons is because we are not emitting CO2, but also because we are the best providing supplementary supporting the intermittent renewable energy sources, as obviously we need in that future panorama where renewables are important, we need nuclear. Here, basically, and my two colleagues are going to enter in more detail after, as Westinghouse in that reshaping the future, maximizing our assets, we are going to focus on 3 main areas. New build, we have AP1000, AP300, Da Vinci, microreactors. LTO, which is extending the life of the current reactors, and also maximizing or making the current reactors more efficient. I would like to highlight that everything related to the new build is very important. It gets a lot of attraction, very visible, but the priority is LTO, long-term operation. That's the condition sine qua non. That's the priority number 1. That's the core of our future. We can build, but we're not going to build fast enough to cover the demands. So basically the priority, the core is on the LTO, and my two colleagues are going to enter in more details. So basically, as an overall, in that, especially working in the three pillars, mainly extending the life of the current reactors that my two colleagues are going to enter in more details. We need to work in three areas: people, processes, and assets. At the end, if you want us to be very simple, it's a lot about people, having the right profiles, the right people, but also making the investments on the right assets. We need to put money. We need to trust in ourselves and invest. So here, so I mentioned that at the end is investing on people and investing on assets. The process, the third area, it comes together with people and investment. As Westinghouse, I think we have been investing since day one, since 135 years ago. We started, producing or fabricating the first PWR commercial reactor that produced energy in '57 in Pennsylvania. And since then, we have been putting money in the system, investing on people and assets. Now, most likely, with microreactors, SMRs, and AP1000 is our biggest reactor. This is, things are becoming more green, even in the map, more focusing in the European map. So you see countries that are planning to extend the life of their current fleet or building new build are becoming more and more. We have more and more green on the European map. Others are newcomers. Poland, Italy is not a newcomer because they phase out, but they are again on this nuclear race. But we are considering them like newcomers. And then Spain. I'm from Spain, and I wouldn't give up. I wouldn't be surprised that Spain can be green in 2 or 3 years from now. It's not, everything is not set. It's not yet. It's not set, let's say. And then I think the focus what I mentioned is more than, very importantly, to focus on new build. We want to focus on maximizing the current fleet, extending, but not only extending, to invest, to make the current plants more efficient. Okay. So basically, and before turning over my colleagues, we have some challenges. The age of the nuclear power plant is 32 years old, average. It's not only that, people, we are the first generation of people with a lot of knowledge that they build the current fleet. They are basically retired or they have retired. So we need to work well, obviously, on knowledge transfer. A bright reality is that electricity through a life extension is more cost competitive because the assets are already amortized, are already paid off. In this aspect, I would add a caveat, and the caveat is that in the current market that the power plants are going to operate in is not the same that the ones that have been operating. It's going to be much more competitive. The renewables, we are going to have to compete with renewables. We are going to have to follow load follow, etc. Right? It means that the market is changing, and we need to react to that changes to stay competitive, even if the life extension of reactor is very cost competitive. An obvious conclusion that I've been insisting is that we are going to, as Westinghouse, we are going to be focused a lot on new build, but equally and even more importantly, we are going to develop a lot of products and services to support the current fleet to enable the extension of the current reactors. And having said this, for entering in a little more details, I'm going to turn over Matt. So thank you.
Okay, good afternoon. My name is Matt Mackay. I am the Director for Global Long-Term Operations within Westinghouse Electric Company. So yeah, as Xavi had framed up here, long-term operations is a global item. No matter which country you look at that has current nuclear, they're considering how do I extend the life of their plants. Westinghouse, we recognize that this is a major factor for the operating plants today. And with that, Westinghouse has organized our business to create a central long-term operations function that is able to engage with these utilities that operate these plants and support them and help them develop on how are you going to efficiently and cost effectively extend the life of your plants. So LTO means different things to different people. So I'm going to talk about how we as Westinghouse describe long-term operations. So I think the first we can see here, license extension. I think that's obvious and maybe what people think about when we talk about life extension of plants. It's fundamental, working with your regulator to extend your license or go through a periodic safety review. Plant asset management, also a very fundamental part of life extension. How are you managing your major components, your systems, your structures? How are you dealing with degradation as this plant's age, neutron embrittlement, obsolescence of I&C, for example? But that is just not, that might be the fundamental parts, but we as Westinghouse and our utility partners consider these additional pieces because you need to think about sustainability of operations when you operate your plants for the long term. So we also include in this items such as performance improvement. Now that might be power uprates, it might be fuel cycle extensions, very important to increase the efficiency of your plant. Digitization. Digitization is it's a large kind of catchment of word, but utilizing digital technologies to help streamline your operations from administration to plant ops to help make you more sustainable, more efficient in your operations. And with that, workforce optimization. What we're seeing more and more now is different models on how to share resources, how to optimize, such as outage optimization, fundamental to, again, the sustainable operations through long-term operations. Sustainability, as Xavi had said, competing in different markets now than maybe where we were in the past. So what we think about when we think about sustainability is additional revenue generation through things such as hydrogen production. That's producing hydrogen using the power from a plant, using the steam from the balance of plant. Radioisotope production. As we've seen with lutetium-177 and actinium-225, the market for this radioisotope production is going to grow exponentially over the years. And Westinghouse has positioned ourselves to help support commercial operating nuclear power plants and being able to support that market. Okay, so that's more of a definition of LTO. So how does Westinghouse fit into this picture of life extension? How can we support our customer partners and being a one-stop shop for life extension of plants? So early in your process, if you are early in developing your business case for life extension, Westinghouse has deployed deterministic and probabilistic tools to help you make those key decisions to approach your board, to get approval, to extend the life. These are major investments in the range of maybe $700 to $1 billion per unit to extend the life of your plant. Licensing. Westinghouse has vast experience in licensing space. We have currently supported a number of plants that have extended from 60 to 80 years of operation. Now these plants were originally design licensed to 40, so being able to support from a licensing aspect to get to 80 has a substantial impact to the plants through life extension. Major components. What do I need to do? Do I need to replace my steam generators? Do I need to replace my vessel head? Do I need to do some refurbishment? This is where Westinghouse's global experience from operating plants for a number of years comes into play. We can help you understand and make those decisions. Key systems. Do I have to have enhanced inspections? Do I need to modernize? I&C, we understand obsolescence is a big challenge. Modernization programs is something Westinghouse specializes in. Getting more power from the plant. As I said, power uprates. Westinghouse has delivered over 150 power uprates globally, and we have supported customers in adding additional megawatts onto the grid. So thinking about that from a life extension point of view, additional megawatts result in additional revenue generated over an additional period of operation, providing additional revenue to their customers. Fuel cycle, working with our fuel teams, looking at fuel cycle extensions, and with that coming, again, more economical benefits of extending the life of your fuel. Additional revenue, as I mentioned, working in different markets, sometimes it may be more cost beneficial to a utility to produce hydrogen when the electricity price is low. We're starting to see load following as being an important aspect of electricity markets now, and positioning yourself for hydrogen is one key area doing that. And finally, I mentioned digitization earlier. Westinghouse has a central digital organization that supports customers with items such as outage optimization. reducing the amount of time that you're in outage, therefore increasing your capacity factors, using digital technologies to help streamline your operating and maintenance costs. So that allows me to hand over to my colleague Manuel, as training and digital approaches have been deployed by Westinghouse to help save customers money. Thank you.
So thank you, Matt. So good afternoon, everyone. So a key challenge for industries anywhere is to maintain safe and reliable operation of their facilities. So this operation critically depends upon the knowledge, the qualification, and the experience of people carrying out different tasks with different levels of responsibility. So if training is critical to any industry, all of you know that it's even more critical in the nuclear industry. So training is key to the sustainability of nuclear power. And this is truer today than at any point in history. If you consider the new build worldwide, the long-term operation of existing nuclear plant, as Matt explained, even the SMR design and deployment, or even the decommissioning projects, okay? So we are facing a growth in the industry worldwide, but we are also facing some risks. First of all, we have an aging workforce. And for sure, we will face a shortage of educated people due to the growing demand from other high-tech industries. Okay, so what we need is a comprehensive training solutions tailored to the client needs, improving the safety and efficiency of nuclear power plant. And this training must cover not only licensed operators, but also field operators, engineers, non-licensed support staff. It must emphasize safety culture. It must implement leadership within the organization. And of course, it must adapt to changing times. It must implement new technologies. So we do have a training model with more than 50 years of experience and thousands of students. A model which is based on systematic approach to training methodology and the best practices of international standards. I mean in INPO, WNE, IAEA, etc. A model based on the performance with the goal of deliver personnel who can perform the work safely, effectively, and efficiently. It's a model which is decentralized, based on the proximity to client and fully integrated with the client organization. A model which is also based on digital technologies. We have mentioned these digital technologies a few times in this talk, with the best instructors, using advanced methodologies, and this is very important, optimizing the investment. We have measured that we can achieve reduction of 20–30% with this model as compared with traditional training models. A model enhancing training results while decreasing the cost of training activities. A successful proven models as a summary that has demonstrated that it is possible to learn faster, to have fun in the process, to achieve better results while investing less money. And how can we do this? With these three pillars that you see on the slide. First, developing engaging material. Digital transformation of all the learning material that will improve the experience. We will use gamification techniques. We will use serious games. We will use quizzes to reinforce the learning and enhancing the internalization, okay? Then we will use learning analytics to improve and personalize the learning path of the students. And we will use collaborative learning and social learning and a high level of accessibility at any time, from any place and any device. Okay. As a summary, we can offer a seamless training model with a higher level of success. And then another key element, critical for nuclear facilities, is the simulation technology. Simulation is, of course, also very important in our training model, but actually simulation is a key technology through the whole nuclear life cycle. In a concept known as simulation-assisted engineering, you can use a simulator in every stage of the life of a nuclear power plant. Okay? You can use a simulator for the conceptual design of the plant, for the design integration of the plant systems. Once the plant is designed, you can use a simulator to verify and validate every and each system of the plant, and also to verify and validate the human factor engineering of the plant. Okay? Additionally, a simulator is also a very valuable tool for the commissioning stage. Of course, simulation is a cornerstone in the operation stage, not only for training, that we have mentioned before, but also for plant modifications. So when you need to carry out a modification at the nuclear plant, first you implement the modification in the simulator. Once you have validated that everything is okay, that everything going smoothly, then you train your people in the simulator. And once you have validated everything and you have trained your people, then you implement the real modification in the real plant. So this is a more effective and less risky way of working. So how can we help in simulations? So we have been developing simulators for decades. Okay? Of every kind, from the small conceptual classroom simulators to the full scope simulators replica of the actual control room. So we have supplied dozens of simulators for the nuclear programs in Spain, in Argentina, in Brazil, in France, in China, to mention a few. And everything we do is developed with in-house technology. Okay, so we have our own software models, logic models, electric models, thermal hydraulic models, neutronic models, and also our own hardware for signal processing. And this allows us to develop tailored solutions to fit the actual client needs. We can then offer the full range of services concerning simulation, from the supply of the simulator itself to consulting services, engineering services, and maintenance and upgrading of simulators. We can supply the full scope. So as a summary of the presentation, we are an international player in the nuclear business, and we are here to help. We want to help because we know that there will be no transition without our industry, and there won't be any energy transition without nuclear power. Thank you very much.
That's it, right?